My dear students, Assalamu alaikum. I hope you all are fine. Today, I am with the 15th lecture on nomenclature of organic compounds, titled Nomenclature of Organic Compounds Having More Than One Functional Group. From this lesson, the points to be learnt are definition of functional group, priority series of functional groups, and examples of some organic compounds to be named. So, dear students, let's begin. The very first point is definition of functional group. Let's write two compounds. General formula of alcohol, and this is the general formula of alkyl halide. Here, this is the functional group of alcohol, that is alcoholic group. Alcoholic group or hydroxyl group, and this is alkyl halide. Here, functional group is halide group. Here, functional group is group of atoms, but here functional group is only one atom. Now, let's see the definition of functional group. The group of atoms or a single atom of a molecule of organic compounds that determines the physical properties of the compound and chemical reactions of the compound. That atom or group of atoms is called functional group. Let's move on to the next point. The point is now priority series of functional groups. Here there are some groups arranged according to their priority. In this series, the topmost group is carboxyl group, then cyanide group or nitrile group, then aldehyde group, then ketonic group or keto group, then alcoholic group or hydroxyl group, then alkene group, and after that alkyne group. When a molecule contains two functional groups, then one functional group is considered as the homologous series of the compound, and another functional group which is posterior one, that is considered as substituent. Simply, the prior one is considered the homologous series or main compound or main functional group, and another functional group which is posterior one is considered as substituent. Let's move on to the next point. The first example is this. Here there are two functional groups. One is carboxyl group, another one is hydroxyl group. From the priority series, we can see carboxyl group is prior to hydroxyl group. Let's write carboxyl group is prior to hydroxyl group. So here the compound is carboxylic acid and hydroxyl group will be considered as substituent. Now let's write the name of the compound. First of all, carbon atoms are numbered in the chain, and in this case functional group carbon is numbered by 1, and this is always. So it is 1, 2, 3, 4. This is butanoic acid, and at carbon 3 the substituent is hydroxyl group. So let's write 3 hydroxy. 3-hydroxy-butanoic acid, single word. Let's see another example. Now the compound is this, where there are 2 functional groups. One is aldehyde group CHO, another is alkene group carbon-carbon double bond. And from the priority series we can see aldehyde group is prior to alkene group. Let's write aldehyde group is prior to alkene group. So this is the compound is actually aldehyde. Now carbon atoms are numbered from the right 1, 2, 3, 4. So this is butanol and carbon 2 with carbon-carbon double bond. So it is 2-butanol. Buty, that means alkene. So its name is 2-butanol. Let's see another example. Let's see the name of this compound. Here there are 2 functional groups. One is aldehyde group CHO, another is alkyne group carbon-carbon triple bond. And from the priority series we can see aldehyde group is prior to alkyne group. Aldehyde group is prior to alkyne group. Now let's write the name of this compound. Carbon atoms are numbered from the right 1, 2, 3, 4, 5. So it will be pentanol, alkyne carbon-carbon triple bond, pentanol, and carbon-carbon triple bond is with carbon 2. So its name will be 2-pentanol. Let's see another example. The name of this compound. Here there are 2 functional groups. One is aldehyde group, another one is ketonic group. And from the priority series we see aldehyde group is prior to keto group. Let's write aldehyde group is prior to keto group. Now this is the compound aldehyde and oxygen is here substituent. Now let's write the name of this compound 1, 2, 3, 4, 5. So its name will be pentanol. And at carbon 3 oxygen atom as substituent. So its name will be 3-oxopentanol. Let's see another example. In this compound there are 2 functional groups. One is hydroxyl group, another one is ketonic group. From the priority series we can see ketonic group is prior to alcoholic group. Ketonic group is prior to alcoholic group. Now this compound will be ketone and this hydroxyl group will be here substituent. First of all, carbon atoms are numbered to name this compound, and it is numbered from the left 1, 2, 3, 4, 5. 5 carbon atoms. So here, and it's a ketone, then the compound will be pentanone 2 or 2-pentanone. 2 because carbon 2 with ketonic group, and at carbon 5 there is a substituent, that is hydroxyl group. So its name will be 5-hydroxy pentanone 2, 5 hydroxypentanone 2 or 5 hydroxy 2 pentanone. Let's see another example. The name of this compound. Here there are two functional groups. One is ketonic group, another one is alkene group. From the priority series we can see ketonic group is prior to alkene group. Let's write ketonic group is prior to alkene group. Now the name of this compound will be, first of all, carbon atoms are numbered in the carbon chain and it is numbered from the right. 1 2 3 4 5. It is numbered from the right to get ketonic group with lower number. Now let's write the name of this compound. 5 carbon atoms and at carbon 2 there is a ketonic group. So it will be pentene 2-one, 3 pentene 2-one, 3 pentene 2-one, 3 pentene, that means carbon 3 with carbon carbon double bond. That is why this is 3 pentene, and carbon 2 is ketonic group, that is why it is 3 pentene 2-one. There is another substituent, that is methyl group, and it is at carbon 4. So 4 methyl 3 pentene 2-one. My dear students, know it today. Thank you very much. Take care.